Get ready for an eye-opening journey into the intricate world of the Gootloader malware. Today, we'll unveil the dark secrets behind its infection process, unraveling the intricate web of compromised WordPress blogs and Windows systems entangled within the threat actor's malicious infrastructure. Prepare to be astonished as we delve into the devious methods employed by these cybercriminals. The threat actor capitalizes on SEO poisoning, cunningly targeting legal terms such as agreements and forms across thousands of compromised WordPress blogs. Imagine a labyrinth of links, meticulously scattered across these blogs, forming what is known as a link pit. Here is an example of one of them. You will see the various terms and links to other blogs. This treacherous terrain serves to boost the ranking of their nefarious pages on popular search engines like Google and Bing. Let's take a leap into the shoes of an unsuspecting user and embark on the journey through the infection process. I have set up a domain-joined Windows 10 system, carefully rigged with simulated files and processes, masquerading as an innocent victim. For our demonstration, we'll choose the innocent-sounding terms Stark Law Exceptions Written Agreement. Even though it may appear at the top of Google's search results, a closer inspection of the domain should reveal that it has nothing to do with our intended search term. However, as an average user, we wouldn't be aware of this crucial distinction. As the page loads, prepare to witness a swift transformation. Like a chameleon changing its colors, it morphs into Gootloader's notorious fake forum posting, a disguise that has fooled users since 2018. But fear not, we won't let these tricks confound us. Armed with the browser's developer tools, we notice a mysterious URL containing a get variable, starting with the letter A, followed by 6 hex values and a series of numbers. The JavaScript code we encounter is intentionally obfuscated, a puzzle designed to baffle even the most astute observers. But don't worry, we've got a secret weapon, Didier Stevens' patched version of SpiderMonkey, complete with a utility known as js-file. With this tool in our arsenal, we can decode the gibberish and expose the truth lurking beneath the surface. Initially, when we try to have js-file parse the obfuscated JavaScript, it throws an error. We can fix this by searching for the first instance of the word for. If you continue on to the word else, you will stumble across a variable before the equal symbol. In this case it is kimwpf. You should also see it with a plus symbol, followed by a semicolon, and then a closing curly bracket. After that curly bracket, add a space and type in document.write open parenthesis, then add in our variable kimwpf. Next add in a close parenthesis and a semicolon. Finally, add a space for good programming practices, and it is time to run it again through js-file. When we run the file again, we get the same error message. This can be ignored, but now we should see 3 text files generated. In the notes below I will add a regex101.com link to assist in the extraction of the needed variable. Behold! The veil is lifted. Look inside of any of the text files, and we discover the deceitful HTML of the fake forum, hiding the ominous download link. But what secrets lie beneath the surface? If we were the blog owners, scouring the WordPress PHP files for traces of the JavaScript we encountered, we would come up empty-handed. However, a cunning twist awaits us within the blog's theme directory, concealed within the innocent-looking functions.php file. Here, we encounter 7 seemingly harmless lines of code that have been added to this legitimate file. Let's dig deeper into this intriguing discovery. The first line invokes a built-in WordPress function called get_option, responsible for fetching data from the database's WP_options table. If we extract the contents of the themes_CSS row, we uncover serialized text, akin to an array. While the initial value CSS might seem inconsequential, a mere decoy imitating legitimate CSS code, the remaining values, such as style, color, fonts, and HTML, hold the key to our investigation. When combined with the 7 lines from functions.php, a hidden world of malicious intent emerges. Let's replace those innocent-looking lines and expose the true nature of their functionality. Here you can see the puzzle pieces fall into place. Within this seemingly innocent code lies a hex-encoded block of text and the means to decode it. By reversing the hex block within the header value and unraveling their encoding techniques, we reveal a remarkable PHP code snippet. For the sake of clarity in this video, I've taken the liberty of renaming some of the functions, ensuring they align with our narrative. As we click on the enticing download link, a zipped malevolent.js file enters our system. Brace yourselves as we embark on an in-depth analysis of what unfolds when we succumb to this temptation. The file reaches out to another compromised WordPress blog, invoking a script called blog.php. This enigmatic PHP code reveals itself to us, exposing its sinister purpose. Once again, we confront base64 encoded PHP code, concealing a sequence of actions aimed at gathering information such as IP addresses, user agents, and referral data. This trove of data is then relayed back to the mothership, my-game.biz, in this case its IP address. Passing through the gauntlet of checks and gates, if deemed worthy, the malicious zip file is presented to the unsuspecting user, ready for download. Now, let's prepare the environment to ignite the malicious file within the confines of the sandboxed Windows system. Our trusty companions, Process Monitor, aka Procman, and Burp Suite, stand guard. Within Procman, I applied a filter to capture only processes containing script.exe. Additionally, we've configured the Windows proxy to direct all traffic to Burp Suite's web interceptor, as well as enabling PowerShell transcription logging. But before we execute the .js file, let's take a peek with a text editor. At first glance, it may appear as a legitimate JavaScript library for Sheet.js. However, a closer inspection unveils its clandestine modifications, cunningly crafted to conceal their malicious intent. By comparing the original library with our downloaded file and removing any matching lines, we uncover a murky world of heavily obfuscated Microsoft JavaScript. Unraveling this enigma exceeds my current capabilities, but fear not, others have developed decoding scripts and tools to aid in this endeavor. But where's the fun in playing it safe? Let's summon our courage and run the malicious file, eager to witness its malevolent effects. With a double click, the file seemingly fades into oblivion. But we won't be fooled by its vanishing act. We'll let it run for 5 to 10 minutes, and then scrutinize Procman to uncover its hidden activities. Ah, behold! A call to task schd.dll, a DLL designed to interact with Windows scheduled tasks, appears on the radar. Curiosity piqued, we explore the task scheduler, stumbling upon an intriguingly named scheduled task, simply social stratification. It executes when the current account logs in, invoking w-script and another .js file hidden within a random app data/roaming folder, residing within the current user's profile. Returning to our trusted companion Procman, we observe the birth of a log file initially, subsequently it is transformed into a .js file. The contents of this file, once again cloaked in heavy obfuscation and adorned with generous padding at the bottom. These efforts are designed to evade detection by EDRs and virus scanners, attempting to dissect its malevolence. But Procman still has more secrets to reveal. Shifting our focus from W-script to C-script, we witness its rendezvous with shell. Command by command, it directly interacts with PowerShell, bypassing the need for saving and executing a file or passing a command line argument. Its sinister methodology means nothing will show in the command line, but we have a trick up our sleeve. Remember, we've enabled PowerShell transcription logging to capture every PowerShell command ran by this wicked threat actor. Let's dive into the logs and uncover their dark deeds. Behold, a series of commands executed and stored within cookie values. The cookie jar holds a disturbing assortment of data, processes and their window titles, a comprehensive list of documents and desktop file names, a trove of Windows environmental variables, as well as drive mappings and available disk space. But that's not the end of the story. These insidious cookies find their way to 10 different domains, their URLs ending with xmlrpc.php. In Burp Suite under the Proxy Intercept section, we eagerly inspect the cookie contents, employing the cyber chef rule to decode their secrets. The first 6 characters reveal a unique system identifier, followed by a digit distinguishing the exfiltrated data. Speculation suggests that the threat actor carefully analyzes this data to determine whether the machine should proceed in the infection process and/or be sold to the highest bidder, hungry for access. And what about the infamous xmlrpc.php file? As we delve into its code, a familiar WordPress file modified for nefarious purposes, its true intentions come to light. Gathering basic system information such as IP addresses, user agents, and the IP address of the server hosting xmlrpc.php, it doesn't stop there. It meticulously captures all get, post, and cookie values, serializing them for further inspection. These valuable morsels of data are then dispatched to a system that is not the mothership, but instead resides at z.co.za. The returned data is evaluated, and if it contains the value GIF89, its contents are unveiled, displaying additional PowerShell code. More revelations await us as we return to the PowerShell code. Any response received from the xmlrpc.php URL triggers execution. With the power of various tools at their disposal, the threat actor can further their infection or expand their influence across the network. Mandiant has documented this intricate dance in a captivating write-up, should you wish to explore it further. That concludes our thrilling journey through the technical analysis of Gootloader. But you may be wondering, what can be done to defend against this insidious malware? Fear not, for I shall share with you some valuable measures to thwart its advances. First and foremost, user education is key. Incorporate screenshots of the fake forum post into periodic training sessions, cautioning users about the dangers that lie therein. Secondly, change the default application for opening .js files from WScript to a more innocuous alternative, such as Notepad. This simple step can fortify your defenses. Thirdly, enable PowerShell transcription logging, a powerful tool that aids in investigations, providing valuable insights into the adversary's PowerShell activities. Additionally, I recommend that your network team blocks any URLs associated with malicious zipped.js files, tweeted from my Twitter/Mastodon/Bluesky accounts. Vigilance is our shield in this ever-evolving battle. If you run a WordPress blog, ensure that plugins, themes, and software are set to automatically update, minimizing the risk of compromise. Consider installing security plugins such as WordFence, which diligently scans your files for any signs of modification or malicious intent. The victim's machine never communicates directly with either my-game.biz or z-co-z.co.za. It is always proxied through a compromised WordPress site as seen within the PHP code.